We saw in example 1 the idea that the domain and range get flipped. They've put that as a special note for you here as well. The next thing we're going to look at is this idea of algebraically, how do you find the equation of an inverse? So they've given me this line in red, y equals negative 3x plus 7. If we want to find the equation of the blue line, which is the graph that you would get if you flipped it over the line y equals x, or you switched all the coordinates, switched all the x and the y, what we're going to do is first switch x and y. Everything that deals with an inverse has this idea of switching x and y. And after you've switched x and y, step 2, rearrange the equation to solve for y again. So if I had this red graph, negative 3x plus 7, step 1, switch the x and y. Instead of having y equals negative 3x plus 7, I would have x equals negative 3y plus 7. After I've done that, now we just need to solve for y. This is our skill of rearranging this equation, just like we did at the getting started. Move the 7 over, divide by 3, and then we get the equation of the inverse. This equation is a function. So you could write f inverse of x is negative x plus 7 over 3, and the original function f of x, this is how this one would be written in function notation. Now, generally, we only write function notation if the original function was given in function notation and they asked us to find the inverse function. In this case, it's just x and y's, so it was fine to leave it as it is. Now, we're going to look at example 2 here. Determine the equation of the inverse. It doesn't say inverse function, just the inverse of y equals negative x squared plus 4. So, algebraically, what do? Step 1, we switch the x and y. Once we've switched the x and the y, now we have to solve for y. And this, too, is very similar to what we did at the beginning of class. If I want to get the y by itself and it's being squared, well, first I'll want to get the y squared by itself so I can get rid of that squared by square rooting. So I'm going to subtract 4 on both sides. That gives me a negative y squared. How do I get rid of that negative in front? Well, I can either divide by a negative 1 or multiply by a negative 1. Once I do that, if I multiply both sides by a negative 1, now I've got my y squared by itself. To solve for y, I would have to square root both sides. Remember, when you square root both sides, that plus or minus to show it could be positive that value or negative that value. And so this is the equation of the inverse. Part B, it says sketch the graphs of the original graph and its inverse. So I'll put a grid here off to the side. Either using your skills with graphing parabolas from last year or your new skills with transformations this year. If I use my new skills, I think of a parabola. That negative would flip it vertically over, and then that 4 would move it up 4. So my original graph, which I'll do in blue here, is a parabola that goes down. I would have to label some points. It has a vertex at 0, 4. Maybe I label 1, 3 and 2, 0 as additional points to show how wide it is. Now, when I reflect that one over the line y equals x, all that I'm going to do is switch my x and y values. So switching my x and y values, instead of 0, 4, and I'll do this graph in green, I have 4, 0. Instead of 1, 3, I have 3, 1. Instead of 2, 0, I would have 0, 2. And maybe you want some points on your other side of your blue graph as well. Maybe you take negative 2, 0. So you can graph 0, negative 2 as well. And when I graph this,
Please report to the office. Kayla Sagan, please report to the office.
I get a sideways parabola. Is the inverse a function? No. It doesn't pass the vertical line test. That green graph, there's lots of places where a vertical line test hits more than one point. That means you plug in an x value and you get more than one y value, and that makes it not a function. Some interesting things to see from this. Okay? Because we found the equation first. What does it mean to graph this? Y equals plus or minus the square root of negative x plus 4. Well, that plus or minus might throw you off. What that plus or minus is telling you is that there's actually two equations that are possible here. One equation with the plus sign, another equation with the minus sign. And now these graphs look a little bit more familiar, and you might say, hey, I know how to graph those. Those are square root graphs with transformations. What would the negative do? Would it be a horizontal reflection or a vertical reflection? Vertical reflection. The 4, would that be a horizontal translation or a vertical translation? Horizontal, because it also is inside the square root. So we have a horizontal reflection and a horizontal translation. This plus 4, does that move 4 to the left or 4 to the right? Right. Not right because you're right, but right because you're wrong. It's going to the right. Why is it going to the right? Oh, confusing. We have a horizontal reflection and a horizontal translation. This is where the special note comes into play. And this is the hardest one to see. The negative in front is so quiet, just trying to be there, all discreet. You have to write this with the negative factored out in factored form, and it's actually 4 to the right, not 4 to the left. Now, if you think about a square root graph, there's my regular square root graph. A horizontal reflection would do what to it? It would flip it this way. And then you take that graph and move it 4 to the left. Can you see that this equation here, and I will highlight it in green, this equation here, highlighted in green, matches up with this part. Can you see the negative square root graph flipped over, move 4 to the right? The second one, again, you would have to write the second one in factored form. If I wrote this one in factored form, factor out, this one has a double reflection. So we think our normal square root graph looks like this. You would reflect it vertically. It now would be like this. You would reflect it horizontally. It would now be like this. And finally, you would move it 4 to the right. That graph, and I'll highlight this in a different color, It is really quite enjoyable to color things in on a smartboard. Anyways, that matches up with this part on the bottom. And because we have both of those parts together, it's not a function. But if we had only one of those parts, it would be a function. Okay, questions to do for this one? R5 and 6. Okay, if you feel like you've done enough math for the day and you feel like you need that little bit of de-stressing, I've got a coloring page up here. What is the most fun to color on a smartboard is to use the built-in crayons. It's like so enjoyable. So what you do is you come up and you pick a crayon color. So I'm going to pick the green, and like really is quite enjoyable. And with the crayon, if you, just like a regular crayon, if you go over it more, it like gets really crayon-y like. Super much fun, enjoyable, and Brock is going to pick the first person that he feels that needs some de-stressing to come up, take the smartboard pen, pick a color. There's more, you can go, there's more colors there if you need, but you can pick one off the top. Who's going up first, Brock? Callan's coming the first up, okay. Then he's just going to pass the pen to somebody else. It is, there's something about it, once you've done it, just is relaxing, makes you feel good. Do the pineapple. Yeah, pick, oh, there's the, going with the yellow. See, it's just altogether enjoyable. He's not done. I mean, that's the other, like, but crayons, you're allowed to go over the line. Like, if you ever try to color something with crayons, you have to go over the line because it's usually like this big blunt object.
Try my best, guys.
Yeah. And if you imagine well enough, you can actually smell the wax while you do it. Oh, very nice. Very, very nice. Right. Oh yeah, you just pass the pen on to somebody else, and if there's someone who just needs it really bad, they'll put up their hand. Here we go. Here we go. Go color. The colors are up at the top, so you can switch the color. Oh, just staying with yellow.
Why are you holding it so weird?
All right, pass the pen on. There we go. Pass it on to someone. If no one's going to volunteer, you force volunteer them. There we go. It's not as bad. I know you're looking into a light, but it used to be when we taught with overheads. The overhead is this bright bulb that shines up into, and at the end of the day, I'd be like, my eyes were like, whoa. Because as a teacher, you're looking at that bright light all day. It was, oh, I got a banana blunder. He's focused right now. She hadn't noticed that part. There we go. Nice. There you go. So if you ever have a stressful day, you got a chemistry test coming up, and you want to come in and extra help and say, can I just color something? Feel free, come in, find something, use the crayons. Look. You would factor out the negative to make it 3 to the right, yeah.
This one I have no clue what I'm doing wrong. Like, I can't get it. I've tried it
Okay.
sometimes.
So, whoa, so sorry.
This one. Thanks.
So what's going to happen here, you move the 3 over, good. You're going to multiply y by negative a half, x by 1/2 as well.
Yeah.
So good, good, good. And then you're going to move 1 to the left. So we've got negative 1, well, you're going to move 1 to the left from here and up 3. So negative 1 comma 3, good. Now as far as plotting that one will be, you're going by 2's here, so negative 1 comma 3 is going to be right there in the middle. Here, you went 1 left and 3 up. Negative 1 plus 3 2's, yep. So you got 0 comma 2 right there. Negative 1, negative, this point here becomes negative 2 comma 2, which will be, and your graph is going to end up looking like that.
Yeah, I was having issues with plotting, I think, on the graph.
Yeah, so your points were there, and then again, what you can also do after the fact is think about how things flip and what the shape is going to be.
First of all, it's still recording.
Oh man, our whole coloring and oh, that's going to be, oh, the last, thank you for noticing that. Okay,